model. We click on our model wizard. Then we choose our space dimension, which we'll be working with. So we select 0D. Then we go on to select lambda battery. So we open electrochemistry, battery interfaces, lambda battery. Then we move on to select our steady. We select time dependent steady. So it brings us to our interface here. So you can see. So we go ahead to add our parameters. We'll load our parameters from our file. So we go on to click here to load, which brings us here. Then we select our parameters. So we select this for our parameter. We go on to double click. Then it adds our parameter, loads our parameters. So we go on to add our variables as well. Which will load from a file. We select this and load. Now we have our parameters. So later we'll define all these variables so that they will turn from this color to black. We want to add table to our results in here. We want to name it as load cycle table. We want to import from here. So it's just after the capacity loss, we use parameter estimation just after this. So this is what we choose. And click on open to load our file. We go on to definitions, then we want to add, before that, I want to add function interpolation to this, which we will name as E and I versus T. Then our data source will be from result table. It will be load cycle. Our function name, we want to change this. and this as well. I want to change the arguments to s and the function argument s. Go to our variables and we realize that all these unknowns have been defined, now turn to black, which is very, very important, because if they are not identified or they are not defined, we'll not be able to compute our work. We come to, we check this section as well. We check the applied current, which we'll be using. We want to define it. It's this. We want to also define the battery cell capacity. And also we want to define the initial state of charge. Okay. We go on to check the cell equilibrium potential. We want to clear this table in here. We want to load from file. We want to choose load our data from file in here. So this will be our file that we want to load. We want to change this temperature to T. We move to the voltage losses. Where we check all these sections. We want to include concentration over potential. We move to steady, then we want to make this a steady load. Load curve simulation. We move to our time dependent, and we want to change our range values. In here. We want to use user controlled and set our relative tolerance to very smaller decimal. We go ahead to compute our work. which gives us our results. We want to set this as our cell voltage title. We want to also change the position to our right for our legend. We move to our global one. And we want to set this as our modeled cell voltage. Move to our global 3. We want to put an expression, go to our definitions, our variables, and we choose this. We want to make some small editing on the manual axis. Change this to 305. But we change here to 3.35. Why am I doing? Change to 4.2 in here. We update. Move here. What's our cell stage of charge? Then we add a 1D plot group. That'll work. Then we'll name this as voltage losses and load, which will go ahead to add a global plot, add an expression, now come to our over potentials, where we select this ohmic over potential, double click to add. So we go on to add another expression. We add one more expression, which will be the activation over potential. We add also the concentration over potential. To this. Once we've added these three expressions, we go on to set the parameter to an expression shown as t. We go on to update our plots. We see our various over potentials shown in here. You can see our ohmic over potential, activation and concentration over potential over a period of time. We want to go on and add the global plot. We'll set this expression as the cell current. We choose this. Then we go on to set the parameter. It's time. We want the line to be dotted. We want the color to be black. We want to plot this. So as you can see, it has been updated on our plot in here. You see the cell current in the graph. Go to our voltage. Take the title off. Want to know what the y and x axis. Want the y axis to be our over potential. You set our y axis to be over potential. And we want to add our global 2 to it. As you can see, it's been updated on our plots. You see our over potential over a period of time. We want to edit our axis. So it has been updated after making some editing on our X and Y axis, and how our plot has been beautifully plotted over here. So we go on to our component 1 to add physics, which we want to do a general optimization. We want to add optimization to this. So we've added our optimization, and we want to do some other, include some other optimization to our work. We want to optimize our work